have a look at a typical question out of an old exam paper for matrics, this one in 2017, and it looked like this. Alright, it gives you an air balloon that is not moving upwards, and that's why it's so important, guys, to read your questions like Sherlock Holmes. Really read it and highlight for yourself. Don't assume, never assume a question, because they do know that the guys who work out papers especially, that you guys are used to having a question being asked in a certain way. So what do? They change one word and it's a completely different question. So extremely important, because what did they do in this one, 2017? They say that this air balloon is moving downwards. Oh my goodness. And it says it's moving downwards at a constant speed of 1.2 meters per second. Then it says it's at that stage at a height of 22 meters from the ground. It drops a ball, and the ball, of course, is also falling straight down. Now, of course, if it was part of the balloon, which traveled already at 1.2 meters per second, I can immediately know that my initial velocity for the ball would also be 1.2 meters per second. Alright, so what else do we have? So that we've got a balloon traveling downwards at a constant speed. It drops a ball. The ball is going to reach the ground. It hits the ground, and now it starts to ask its questions. Okay, the first question they ask, which of course is not a definition, always starts a question with a definition, is this balloon in free fall? Alright, let's think about that. Is the balloon in free fall? No, of course not. Why not? Because what do we know to be free fall? We know free fall is when the only force working on it is gravitational force. And then it would have been that this balloon should be then accelerating towards the Earth at 9.8 meters per second squared, which it doesn't do. It goes with a constant speed. Therefore, there must be an extra force acting on my balloon upwards that absolutely has the same velocity or acceleration as downwards. So therefore, I have a zero acceleration of naught. Okay, so my answer would be no. Why not? It's not in free fall because it's traveling at a constant speed. Therefore, there's not only gravitational force working on it. Great. So let's start with the problems. The problem, the first one they asked, to calculate the time that it takes the ball to reach ground. Alright, so what they ask, we've got initial velocity as 1.2. They're going to ask me the time, so I have to work out delta t. What else do I have? Now I don't have a final velocity, I don't know what it is. What else do I have? I've got g as 9.8, and I've got delta y as 22 meters. So the moment I don't have a final velocity, the formula that I can now use would look like this. Let's just make sure they're asking for time. Great. They do give me delta y. I do have initial velocity, and I do have my acceleration. Great. This one can work. Now, very importantly, what do I choose as my positive direction? Well, both of these objects are going downwards, so I would be pretty stupid not to choose downwards as my positive. Alright, so let's choose down as positive. So then I can go and say, alright, my delta y would be 22, initial velocity 1.2 t plus a half 9.8 t squared. And if I would then, let's just get this, 22 1.2 t plus a half of 9.8 gives me 4.9 t squared. Then I could have that I have 4.9 t squared plus 1.2 t minus 22 equals 0. And if you would put that into your calculator, use your formula for a term, and then you can get your t as 2 seconds. So it does also give you a different value for t, but a minus, the time can't be ever negative, so I use the positive, so I get a 2 seconds. Of course, I could also have first worked out my final velocity, and if I've got my final velocity, I can then work out t. But then, of course, I would then use two different formulas to get to the same answer. So but any one of them is correct. When you work out old exam papers, you always see there's a lot of options. You could either have worked it out like this or like that. Just believe in yourself and keep going. Right. Now let's have a look at the next question. So that was pretty easy, don't you think? Okay, so let's see what they ask now. Now they continue and they say, when the ball hits the ground, it is on the ground, staying there for 0.3 seconds. Boink. So it goes onto the ground, touches the ground for 0.3 seconds, and then only bounces back. So it bounces back with an initial speed of 15 meters per second. Alright? So let's get it straight. So we see ball is falling to the ground, stays on the ground for 0.3 seconds, then bounces back. Right. Now what is the question? The question is, you have to calculate how high is the balloon from the ground, from Earth, at the same point as when it reaches, the ball reaches its highest point. Okay, let's just think of that again. What exactly are they saying to me? They're saying, we want to know what is the height of the balloon. Now remember, the balloon is moving downwards. So what is the height of the balloon at the same time as what the ball needs to bounce back towards its highest point? Now let's first have a quick look at the balloon. So our balloon, we know, travels with a constant speed. And you do remember that I told you, when you have a constant speed, you can use that the distance traveled by the balloon would just be then equal, V equals the distance divided, or the delta y divided by your time. Now my problem is, I've got my speed at which the balloon is traveling at a constant of 1.2 meters per second. I do want to work out, yes, what is the distance it traveled there, divided by t, but I don't have t. I don't have the time. But wait a second, that is why they then gave me the ball. So what is the ball doing in the same time that the balloon is traveling downwards? The ball is falling down to Earth, hit Earth, stays there 0.3 seconds, then bounces back to its highest point. What would be the speed at its highest point? Of course, V final, 0. So can you see at this there, I've got the initial velocity and a final velocity. Chose downwards as positive. I've got the time already for the ball when it falls down. So that means if we can get the time for the ball, it would be the same time for the balloon to travel. So there it is. So I just first need to figure out what do I actually have to work out? So if I don't have the time for the balloon, but why did they give me all this 0.3 seconds of the ball on the floor? That's the reason why. So, what is the total time of the ball? It fell to the ground in 2 seconds, we worked that out already. Plus, it's going to stay there for 0.3 seconds. Perfect. Plus, it takes a certain time to bounce back to its highest point. So can you see, I first have to work out that time. So I do have V final equals V initial plus A delta T. Just remember, downwards is positive, and I'm now going in the opposite direction. Of course, my final velocity is 0, but my initial velocity in that direction is minus 50. Acceleration is in the same direction that I chose, plus 9,8 t, and I get my t, the time for it from there to there, and let's just work that out. Okay, I did quickly work it out before, and I got to my t as 1.53 seconds. So now we can see that the total time for the ball traveling down on the ground, bouncing back, plus 1.53 equals 3.83 seconds. So I'm going to add that 2.0.3 plus that 1.53, and it gives me a total time of 3.83 seconds for the ball to reach its highest point. And in that same time, my balloon traveled downwards. So I've got a time then here from 3.83, and I do get then that distance traveled, and it worked out. Let me just see where did I work it out. I've got in that 3.83 times 1.2. I worked it out as 4.5967 meters. But remember, that wasn't the question. What is the question? The question is, how far is the balloon from Earth or from the ground at that same point? So not how far it has traveled, but how far it is from the ground. But it was 22 meters to start with. So if it did travel 4.5967 meters, then we can just work that from then out. So that means it's 22 meters minus 4.5967 meters, and I did get the answer of 17.40 meters above that level, or above ground. Right, so there you can see a typical question. How do we approach it? What do we have to be careful for? And especially, read your question. Guys, believe in yourself. You can do this.